Hi, my name is Mihai Keveti. I'm the CTO for Cloud Native and Red Hat Solutions for IBM Cloud Solutions Center. And here with me, I have Craig Brandt, Senior Solution Architect at Red Hat. And we're going to give you an overview of the OpenShift console. And we're also going to introduce some of the things that make OpenShift exciting as a platform for development. So let's get started. Craig, can you give me a quick introduction about yourself and some of your experiences with OpenShift?
For sure. As you've mentioned, my name is Craig, and I'm a cloud solution architect for Red Hat, and particularly focusing on and having a passion for automation. Absolutely loving what's happening in the Kubernetes field and what we're busy with doing with containers right now. I've also been lucky enough to deal with and work with a lot of different customers in a lot of different sectors. So perfectly happy to talk about what we're going to do with OpenShift today.
Hey, that's excellent. Thank you for the introduction. So here I have an OpenShift cluster. I've provisioned this on IBM Cloud, and obviously you can do the same on premises or on any other cloud platform. And I've logged into the user interface. So just looking at this, right, at a glance, what can you tell me about the OpenShift UI? What can you tell me about the views? Or what are some of the interesting features that we see here?
One of the main features and what is important, what we've done with OpenShift is we've included a lot of different views and a lot of different components which are usually disparate. We've put into a single UI. If you look on the top left-hand corner, you'll see that there is actually a view for an administrator, and there's a view for a developer as well, because even though they're working on the same platform, they do need to perform different tasks while working on that as well. We've also got metrics and some graphs to enable the operations team to have a better view and a quicker view of what's happening within the platform itself. But there's also a great developer view which simplifies the experience for them, which I feel is important. Developers don't want to really know about the underlying platform more than their speed and velocity at which they develop. We also have integrated logging and metrics to help plan, help decide, help monitor what's happening on the OpenShift platform.
Okay, thank you. So while you were giving us this introduction, I was exploring the UI here a bit. So let's start with the developer view because this is more interesting. Before we deep dive into everything, I want to ask what makes this developer view different? What are some of the key features that I'm looking at here on the screen?
There's a lot of key features there. What I feel is extremely important and what we're aiming for cloud and that cloud experience is being able to provide a service catalog. A service catalog that is easily consumed by developers, but also that service catalog is something defined by the operations team. In other words, the operations team can automate and ensure what the developers are consuming, they're able to report on. The security teams are able to ensure that they comply and that they can be audited on it too. So you'll see on that interface, there's almost a wizard type experience that you can provide to your developers if they need to choose something from the catalog, and a lot of aspects to ease and to make it easier to do the builds into the containers, which is what they need to do, right? Is need to focus on the code.
So you've made a very interesting point there that this is a customizable view. This is something that you can design in a way which applies to your development, to your team, to your organizational structure. This feels to me like having my own private cloud environment where I control what's going into the catalog, I control the services that I have access to, but I can also design them around specific workflows. Would that be a correct statement there?
For sure, absolutely correct. And on that point as well, what OpenShift does offer is several ways to build your container or your application. What we include with OpenShift as well is we have certified images, we have certified libraries and frameworks, which will ensure that the supply chain, which is open source these days for development teams, has been secured, is supportable, and something that they can easily consume with the protection, the support, the knowledge base of what Red Hat can offer too.
So that's an interesting point, and just to explore that a little bit, I want to switch back to the administrator console and talk about how do we actually deploy OpenShift. So how is OpenShift deployed? Because one of the things that I've noticed when I've moved to OpenShift 4.0 is the introduction of CoreOS. So what can you tell me about CoreOS and what kind of benefits does it bring from a security standpoint, from a management standpoint? How does that change?
Great points, and actually something really a fantastic feature that came in with OpenShift version 4. With including the CoreOS technologies, what we've been able to do is actually create an immutable operating system. And when I talk about immutable, it's an operating system that is basically read-only. And Mihai, as you know very well, containers are the underlying operating system. So the first part that we need to ensure, and what we have done, is the RHEL kernel is absolutely the same kernel that we've got in CoreOS, which comes with that heritage of the 70 plus years of experience we have with providing an enterprise Linux, but also the contributions that we do upstream as well. Now, another advantage of an immutable operating system, and we'll touch on the operator framework later, is an immutable operating system ensures that the management, the operations is something that actually OpenShift can provide through the console as well. Instead of the operations team having to worry about patching, having to worry about ensuring that there's a consistent version. This is all now managed through OpenShift as well. Coming to the installation process, which is automated, we have two types. We've got the installer provisioned infrastructure, and that is a fully automated process where we will spin up the OpenShift by using the APIs of our certified cloud providers. We also have the user provisioned infrastructure, and that allows you more customization. It allows you to deploy on perhaps certain environments that we don't have a cloud provider for, but we give you that ability to choose both of them as well.
That's excellent. And look, from a personal experience, as I've moved to OpenShift 4, I've noticed it's a lot easier to deploy OpenShift. The integrated API installer definitely makes things, very easy. You pointed at the cloud provider, you pointed at the private cloud infrastructure, at OpenStack, at RHV, and you say, just configure me a cluster. But it also seems to have some other benefits post provisioning. It seems that some of the automation capabilities that you have during installation carry on after installation. So can you talk to me about machines and machine sets and how those are influenced by this immutable operating system and this way of deploying the cluster?
Absolutely. Because the operating system is immutable, there will be certain times where you would like to configure the operating system, or perhaps you have a special node that has GPUs on it, as an example. Somehow you need to still be able to customize that operating system. However, what we've done is we've included something called operators. And we'll touch on operators a little bit later, but those operators actually provide you a fully automated operations experience. So you consume or subscribe an operator, configure that operator and tell that operator what to do, and it actually takes care of what's happening in the underlying operating system.
So automation is key really for managing OpenShift, it seems.
Oh yeah,
All of the one, I guess one way to put it is that this new version of OpenShift manages itself. It's got the built-in automation. What about the security posture? So it's definitely a huge boost when you've moved to an immutable image, right? It's much more difficult for attackers to do anything within your operating system space. But what about preventing, let's say, somebody escaping from a container? Or can you tell me about some of the core securities that I used to have with traditional Red Hat Enterprise Linux operating systems? How do those carry over to CoreOS?
absolutely. Also, a fantastic point as well is security is not something that should be at the end or an afterthought, right? It should be an integral part of what you're doing from your development, your operations as well. And with what we've built into the platform, what we've got from RHEL. So as an example, we have something called SE Linux, which provides an additional abstraction and isolation between pods. Now, you can imagine that if your operating system has a vulnerability, guess what? That vulnerability can be exposed and consumed and utilized and taken advantage of in your containers as well. There's actually, interestingly enough, been a couple of CVEs that we, because we employed SE Linux, the CVEs that affected Kubernetes actually saved our customers from it as well. And that security moves up the complete stack as well. So Kubernetes, absolutely the heart and soul and the orchestrator of it as well. So what Red Hat provides is proper versioning, right? Ensuring that the version that we provide is patched. We provide over-the-air updates now, which is great for OpenShift 4. And once again, speaks to that immutable operating system, so to being able to do that. And we did touch on, the new supply chain for developers is open source. But there are some interesting stats and interesting surveys that do mention the time it takes to actually do a vulnerability patch in a widely used library, widely used framework is just not at the enterprise level that we need. Hence why we've added that registry, the Red Hat registry, container registry, which allows you to consume or provide the developers the ability to consume something that is safe. So we have it through the whole stack. Our default security posture, if you take a plain Kubernetes, now the default of that is it allows everything. It's also a flat network. You still need to build in your SDN. Somehow you need to build in your authentication. And what we've done with OpenShift is we've created that full PaaS solution. So our default security posture is that of restriction. And with the advanced role-based access control that we provide and security context constraints as well, that gives the operations and the security teams the ability to ensure that there's fine-grained control and security measures put in place, but the developers still can have that innovation and move quickly in a safe playground.
One thing that I've experienced over the years with SE Linux, um, everybody understands it's powerful, but nobody tends to use it because it's very easy to turn off and then just don't worry about it. One thing
Yeah.
I've noticed with OpenShift is that it's on by default, but I never noticed it's there. It seems that somebody's done the work for me behind the scenes to create the policies, to profile everything, and to make sure that the syscalls are secure and so on and so forth. Is there anything I need to do to configure it or to get, let's say, get the benefit of the security posture, or is just there for me?
It's inherently built in. When you do the deployment, when you're doing the installation, that's all taken care of. And we feel that's important. And where Kubernetes and clusters are moving to, clusters are used to be cattle, right? And they're slowly moving towards pets. And with that, and with the automation that we're providing to deploy these clusters, it used to be quite a big job. But using what we've provided to deploy, you start getting that feel where you can deploy new clusters very easy, and you do deploy clusters more on demand. And that's quite a different mindset that the operations teams can provide, though it's a far more efficient model.
So let's talk about the operators, because you got me really curious to understand some of these things in depth. So one thing that I've noticed when I was exploring the operator um, hub is this is definitely something new with OpenShift, right? But it seems to be a very powerful construct. So I'm going to scroll down here to the capability level first. What can you tell me about the capability levels, and what are some of the advantages of having operators which are higher on the capability level tier?
Well, look, there's an operator hub, and this is something that Red Hat has also contributed to the upstream. We 100% contribute to the upstream. Though the operator framework is, in essence, allows the operations team to codify the complexity of looking after an application. Think about a database. If you needed to go and scale a database to an additional node, think about a load balanced web application. How do I go into the load balancer, make sure that I'm adding an extra point there? All these complexities can absolutely be codified, like I've said, and then deployed in a manner that allows the developers to consume this as well, which is important, right? So they don't have to worry about the intricacies of integrations and worry about the intricacies and complexities of creating storage or replicating databases. And with this framework, it's actually there's a lot of momentum with it. And certified operators is something that's come up within that catalog that you're looking at right now. So we have a certification process where external vendors come to us. We provide the testing framework for them. And that allows you to, or allows you as a company, you as an operations team, you as a developer team and a security team, right? That whole DevSecOps feel, able to consume third-party vendor software in something that is already has that encapsulation of the complexities taken out for you, something that is easily consumed via that portal.
Craig, over the last couple of years, well, maybe the last 10 years, 15 years, I keep hearing, DevOps this and SRE model that and shift left, but I've never really seen it in action to this degree. And one of the things I found to be interesting about the operator framework was that it really tries to automate the day-to-day operations. Anything from your basic installation and small upgrades to full life cycle, where it generates and it has the code for things like backup and monitoring and management and high availability and disaster recovery, to deep insights where it gets access to logging and monitoring, all the way to autopilot where it even does self-tuning and auto-scaling. So the moment that you have a operator in place on your OpenShift platform, it seems to me a bit like you have your own platform as a service for that specific product. So if I have to, just to take an example here, if I have an operator for MongoDB installed, which gives me the capabilities to create a database, and by default this will be highly available and I have a way to back it up and all those things in place, it almost seems to me like I have not just a catalog of things I can install, but a catalog of services that come with the management included.
Fantastic points. Very eloquently put. I think you've really touched on what the operator framework is trying to do. And you also spoke about, we hear the buzzwords DevOps, we hear the buzzwords DevSecOps, but to take that buzzword and make it into something meaningful, into something that actually shows business value, it takes a lot. One of them is a platform where all of them can work and participate together. Instead of having disparate platforms and disparate systems and processes, OpenShift provides that automation for the operations. It provides that inherent security that we have for the security teams. And we also have a great ISV model that allows OpenShift to be integrated with what other security products or whatever protocols and governance that business has. And of course, the developers don't want to be Kubernetes developers. They want to develop on things that have business value. It's all about out experimenting the competition. And of course, there is a culture component to this as well that needs to be taken into consideration and the processes to match so, but you need that platform where everybody's working together.
So you've touched upon developers. What about operations folks? Let's say that I have my own custom software that isn't available here, right? And I want to write an operator for that. What options do I have?
The operator framework is quite comprehensive and does give several options for the operations teams to do so. What we are finding is the default language for operators is Go, which has quite a steep learning curve, especially if you're coming from an operations background, myself included, right? I could be dangerous with a bit of development, Though what we've included with the operator framework is the ability to use Ansible
Hmm.
to do so. And if I can understand and consume Ansible, I'm sure a lot of people can understand and consume Ansible. And that allows a quicker or a shorter learning time to be able to start codifying the complexities of your operations. And it's all about how quickly we can provision these resources in something that the operations teams can report on, can ensure compliance on as well. How better to ensure that consistency with automating and putting it in an operator that can be consumed by the development team or additional operations teams as well. And remember that Ansible as a language expands past the OpenShift. Ansible really provides that glue for the operations developers, security teams to be able to really form part of that CI/CD feel, right? Being able to automate a lot of what they're doing and feed into that pipeline that the developers are using currently.
Uh, I think that's an excellent point there, Craig. And I was thinking, from a continuous integration perspective, I have source to image. I can use either Jenkins or I can use OpenShift pipelines. But from a continuous deployment perspective, um, it seems to me like maybe Ansible or Ansible Tower seem to be a better choice to achieve that continuous deployment, especially if you're interacting with external components. And I was looking through the catalog and I've seen, for example, operators for cloud providers or operators for external components. So at least to me, it seems like operators don't just manage things within the Kubernetes environment. They can
Mm,
also connect to things which sit outside of your Kubernetes environment. If you're deploying OpenShift on top of IBM Cloud or AWS Cloud or Azure Cloud or your own environment or VMware, perhaps you want to control the storage or you want to control the load balancer or you want to control some external service. And it seems to me like, at least by default, the operator framework comes with such constructs.
It absolutely does. It absolutely does. And you touched a little bit on using Tower to perhaps take it a level further and not just using it within the OpenShift construct, but being able to automate and codify your security requirements or your auditing requirements. Think about all the networking devices that need to be configured and setting up VLANs for this application to run, or ensuring load balancers are configured properly as well. That integration and those extra hands that and glue that Ansible provides is a really strong framework and a strong story when you look at it in the context of OpenShift. Absolutely, it's a PaaS, but as the operations teams and the security teams and the development teams well know, that there's more to it than just the actual container. There is a lot of enterprise compliance. There's a lot of complexity that is abstracted by Ansible when moving to different clouds, etc. And OpenShift also provides that consistent feel, that consistent look, that consistent platform when you move into a hybrid and multi-cloud environment.
What can you tell me about the advanced cluster management feature?
Sure. The when we touching on that topic of multi-cloud and hybrid cloud, and we also briefly spoke about how clusters are becoming cattle, moving away from pets, and the ability that has been built in to now automate these deployments means that it gives the capability to run on multiple cloud providers and on premise, though there needs to be a level of management that happens across these. You can imagine as an operations team trying to find a fault on a container, or trying to see what the resources are, but you have no idea which part to start at or which cluster to start at. The developers need to really, if they're trying to debug an application, can you imagine trying to log into several clusters over several different cloud providers to find that? And never mind the first security guys that need to ensure that this is patched, compliant, and can provide evidence that it's audited. there's a need for that cluster management layer happening above as well. And that's where Red Hat Advanced Cluster Manager comes into the picture. What we call it RACM. It wouldn't be IT if we didn't have an acronym for it. But what that provides is, and you touched on the point that it provides services for a lot of different Kubernetes platforms as well as OpenShift. And it does give you that single pane of glass, which allows, we touched on DevOps, right? DevOps need to deploy quickly. However, they need to deploy consistently too. So that gives the ability for those DevOps teams to do so. The security teams can apply compliance postures. They can also receive and create evidence for in order to do so via the RACM framework and the RACM interface. And developers also have the ability to decide where they want to deploy these applications. They can deploy it on multiple clusters. They can deploy it on a single cluster based on the requirements of the application. But I'm also a firm believer in that it's about the right application on the right platform. So you need to give them that freedom, that ability to do so. And that's exactly what RACM provides.
So just exploring some of the things I see here within the user interface, I see an observe environment view where I can see the topology and the number of clusters that I have configured, the applications and the security policies that I have deployed. Right now I've imported one cluster and I can deploy applications on it. I can set policies, but I also see something here when I go to the cluster view, which seems to be rather interesting, which is a provider connection. So I can connect to a cloud provider. So I put in my credentials for my Azure account, and it seems that now I have the ability to create OpenShift clusters on multiple environments just using RACM. So can you talk to me about this, or what are some of the key capabilities that you see when you deploy clusters using RACM?
It's about, first of all, it's about consistency. If you needed to go and deploy several different clusters on different cloud providers, you're able to do so and provide a configuration to do so throughout the different providers, as well as to make sure it's consistent as well.
So let me start by introducing the pipeline operator first. What can you tell me about OpenShift pipelines and how do these help the development process?
You've hit the nail on the head where you spoke about you'll need a separate build team to patch and manage and look after extremely critical parts of the development process is that actual build server. Now, as we move into more cloud native types of applications and cloud native practices where we're busy developing as well, what we're doing now with OpenShift pipelines, which is based on Tekton, is providing and giving that power, giving that capability back to the developers. What the OpenShift pipeline provides is a cloud native build pipeline that can be consumed within a project. It's something that can be consumed within a team. And instead of having to add an additional step or an additional process to start building your applications, this is actually something where the developers have control again of how that CI/CD pipeline looks like. They can quickly spin one up, spin one down when they don't need it as well. So it's about removing the different barriers to innovate, right? To get your product from an idea into something that is consumed by a customer. So giving them that flexibility and not having to worry about passing this on to a build team, we've integrated that and provided that service as something the developers can use within their own constraints.
That's quite cool. And look, one of the things I've noticed with pipelines is that I can take my pipeline with me. I can commit it to my application, which kind of, well, it helps me avoid a lock-in, right? Because one of the issues I've had with setting up CI/CD environments is every time that I change the environment, I need to completely change my tooling, my deployment pipeline, my processes, my just about everything. Um,
Mhm.
with pipelines, it seems that I just commit a pipeline in the form of code to my Git repository, and I carry it away with my application. So I'm giving the control of the deployment, I'm giving the control of the CI/CD process back to the development team, but I'm ensuring that all of the operational aspects are followed through, and I have the operator for pipelines that make sure that this runs within my OpenShift cluster the right way. Is that correct understanding, or do I have the feel for this?
You've got it spot on there. One point that you mentioned that was extremely important is if you're going for that hybrid multi-cloud experience and what you want to provide to your organization and developers, you want to try and avoid you getting locked into perhaps one solution. You need the ability to be able to port your applications across without having to redevelop or refactor your code if you want it to be consumed on another provider as well. So that is absolutely true for the CI/CD pipelines, but a lot of the aspects of OpenShift as well.
So that's excellent. And look, I think the last thing I want to touch on with you here is CodeReady. So I've noticed that one other thing that ships with the operator framework is an operator for CodeReady Workspaces. So I've deployed this onto my cluster, and let me see. Here is my deployment. I'm gonna click on the URL, and let's see what I get. Because typically, and I remember this, back from my development days. Every couple of weeks, developers would reinstall Eclipse, or they would reinstall all of their development tooling, and they'd install plugins, and the plugins wouldn't work, and everything would break, and it would be quite spectacular to watch. And a developer would build something, then another developer would use a different environment, and so on and so forth. And if we change languages, those need to change as well. So I've noticed that when I install CodeReady Workspaces, I have access to some pre-configured development environments that can use either an Eclipse, Che, or Visual Studio Code Web Edition type environment for Python and PHP and Go and a bunch of other programming languages. But I also can create custom workspaces with .NET or C++ and so on and so forth. What are some of the benefits of having an environment like CodeReady Workspaces compared to traditional development?
You've touched on a good point there, as well as you spoke about the sprawl that you sometimes get within development teams where they're using different IDEs and different ways to deploy it. What the CodeReady Workspaces provides as well is the ability to quickly build and quickly develop containers on the OpenShift platform as well. So if you write code on the CodeReady Workspaces, you have built-in capabilities of deploying that application within OpenShift as well. It's true. And for VS Code as well, there are OpenShift plugins that are available. Now, it's also about, let's take an example. A new developer joins an organization. How long does it take to get that developer to start being productive? Look at how easy CodeReady Workspaces there. You actually install the operator and you had something to go, which provides the organization and the developers a quicker time to start being productive. And it's also a consistent environment for them to start being productive. And you know what? If we're building cloud native applications, let's use a cloud native IDE as well.
The first time I've seen this in action was at DO500, DevOps Culture and Practices course by Red Hat. It was very strange because so I joined the course, mostly to observe, see what's going on, and experience a week of, the Red Hat method of doing things. And a lot of the course participants had no experience in either software development or had limited experience, let's say, developing code. And still they were to get started so fast because they were given access to CodeReady Workspaces, they were given instructions, they had the ability to deploy everything to OpenShift, they had access to the services. I just can't imagine running a workshop like that with participants and say, okay, first you need to install Eclipse. What's Eclipse? Oh, oof, okay, so you need to okay, you're using a Mac. Oof, okay. You're using Linux. Okay, you should. Well, if you're using Linux, I'm not gonna teach you anything you should know. You're using wrong version, right? And this, do you have a web browser? That was basically the only requirement. And it was strange because people had to bring in their own laptops, right? We weren't giving them workstations or anything like that at the course. Well, you. So point your browser at this URL. The lab was somewhere on the cloud, I guess. And it was an interesting experience. Now that we have CodeReady Workspaces available, let's see if we're able to write a very simple hello world program. So I'm just going to create here a hello.py. I'm going to type print hello world and let's see what happens. Just going to make this a bit bigger. Whoops, too big. Yeah. And we're also going to install pylint. So we have some tools in here. I'm going to use pip install pylint. Yeah, so now you can tell me if my source code is written correctly. And I'm going to press F5 to run it. There we go. Hello world. So thank you for the time there, Craig. I really appreciate your coming in on the show. And we'll see you again another time. Thank you.